geometry, these are the notes for section 7.4 on parallel lines and proportional parts. So we're going to practice what you're going to do on Tuesday and Wednesday in class when I'm not here. And you're going to follow along on the notes and copy them down, and then you will start working on your assignment. So, first off, the triangle proportionality theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So what that means is, in this picture, if DE is parallel to AC, and remember the triangles show that two lines are parallel to each other, then that splits up the triangle into some proportions. So BD is proportional to DA, which equals BE over EC. Okay, so if those lines are parallel, then it breaks up that triangle into proportional pieces on both sides. The converse of this statement is also true. So if those segments BD over DA is equal to BE over EC, then the two lines have to be parallel. So remember, the converse just switches the hypothesis and the conclusion, so this is true both ways. Okay, so we can use this theorem to help us solve for missing sides in triangles because of these parallel lines. Also, as you're taking notes, if you feel like you missed something or you need to pause or go back, fast forward, whatever you need to do, that's the advantage of watching these notes on your own, as you can go at your own pace. Okay, so let's look at example 1. And we may not do all of the examples on the poster notes that I provided for Tuesday and Wednesday. I filled out most of the examples, and I'll try to do the same ones in the video notes. Just do the best you can. So, looking at example 1, we see that these lines are parallel, so I can set up a proportion. I can say 14 over 12 is equal to x over 15. Remember, you could also go the other way. If you did 12 over 14, that's the same as 15 over x. As long as when you cross multiply, those are equal, then the proportion doesn't matter. So just be consistent as you're working through. Okay, so we're going to cross multiply and divide. So I'm going to do 14 times 15 is 210. And then 12 times x is 12x. We're going to divide both sides by 12. So 210 divided by 12 is 17.5. And yes, you will probably get some decimal answers on these. Since we are solving for x in a triangle, go ahead and round to 1 or 2 decimal places for your answers. Okay, let's jump to number 3. So notice on number 3, we're missing a piece of information from this picture. We don't know the length of this little segment, but they told us the length of the whole side is 55, and part of it is 45. So if I do 55 minus 45, then this piece is going to be 10. Which is what I need. I need the little pieces of the side of the triangle to set up my proportion. So for my proportion this time, I'm going to do x over 36 equals 10 over 45. So then when we cross multiply, this is going to be 45x equals 360. We're going to divide both sides by 45. So 360 divided by 45, x will equal 8. Okay, let's go to number 5. Okay, so same thing. We're going to set up a proportion. We're going to say 30 over x plus 7 equals 25 over 15. So this time when I cross multiply, I'm going to have to multiply 25 times x and 7. So 25x plus 25 times 7 is 175. 30 times 15 is going to be 450. Okay, so now we're going to subtract 175 from 450. So 25x equals 275. Then we're going to divide both sides by 25. So 275 divided by 25, x equals 11. Okay, so on 7 and 8 it says determine if MN is parallel to JL. So to show that these lines are parallel, we're going to check the proportion. I want to see, is 11 over 15.4 the same as 10 over 14? So remember, you can divide each of those fractions and reduce them on your calculator, or you can cross multiply. So if I go ahead and do 11 times 14, that's 154. And then when I do 10 times 15.4, that equals 154. So as long as when you cross multiply they equal each other, then yes, they are parallel. So you would say MN is parallel to JL. We're going to do the same thing on number 8. I want to see, is 18 over 5 the same as 15 over 4? So if I do 18 times 4, that's 72. And then 5 times 15 is 75. Those are not equal to each other, so these lines are not parallel. So you could say not parallel on this one. Okay, so that theorem works by saying that the lines are parallel and setting up a proportion, or if you set up the proportion and they are equal, then the lines are parallel. It works both ways. Okay, next step says proportional parts and parallel lines. So it says if 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So notice we've got 3 lines that are parallel and 2 other lines that intersect all 3 of them. Those are the transversals. So in this picture, it's showing that AB is parallel to CD and parallel to EF. Since that is true, what this theorem says is that AC over CE is proportional to BD over DF. Okay, so we don't have a triangle in this picture, but those parallel lines are cutting off the transversals proportionally. So we can set up a proportion and solve. Okay, so let's go to number 10. So because these lines are parallel, I'm going to set up my proportion. I'm going to say 45 over 18 is equal to 52 over x. Just be consistent as you're setting up your proportion. So when I cross multiply, 45 times x is 45x. 18 times 52 is 936. When I divide 936 by 45, x will equal 20.8. Okay, let's jump to number 15. Okay, so we're still going to set up our proportion. We're going to do 2x plus 2 over 21 is equal to x plus 3 over 12. So when I cross multiply this time, we're going to distribute because there's more than one term in the numerator of these fractions. So 12 times 2x is going to be 24x. 12 times 2 is 24. When I go the other direction, 21 times x is 21x. And 21 times 3 is 63. So now we're going to solve for x. So I'm going to subtract 21 from 24. 24 minus 21 is going to give me 3x plus 24 equals 63. I'm going to subtract 24 from 63. So 3x will give me 39. When I divide 39 by 3, x will equal 13. Okay, so now you're going to start working on your assignment. You are doing all of these questions, and if you have questions, you can ask me.